Hi everybody, in the previous video I talked about how do we find the stationary point and how do we use the first derivative test or the second derivative test to determine the natures of the stationary point that we found, right? So this is the second part for this topic. This question asks us to find the stationary point and also to determine the natures of each stationary point that we found. When we look at stationary point, first thing come to our mind is dy by dx is equal to 0. Okay, let's look at part A. Y is equal to 1 over 5 x minus 2 raised to the power of 3 plus 1. We want to find the stationary point. First, we find the dy dx first, the gradient function. Dy by dx. Okay, so to differentiate this function, I think it should be no problem, right? Bring the 3 over here, bring down here, times 1 over 5, then you will get 3 over 5. Copy this, x minus 2, the power you always have 2 minus 1. Okay, differentiate inside here, you will just get 1, you don't have to write 1, is okay. Differentiate a constant, you will get 0. Okay, so dy by dx is equal to 3 over 5 x minus 2 raised to the power of 2. Okay, so we want to find the stationary point, right? Dy dx equals 0. X stationary point, we know that dy by dx will be equal to 0. So this whole thing is equal to 0. Okay, so 0 divided by this whole thing, you will still get 0, right? Okay, you square root both sides, you square root 0, you still get 0. So x minus 2 is equal to 0, x is equal to 2. Now we got the x coordinate for the stationary point, but we need a complete coordinate for that stationary point. It means that we need the x coordinate and also the y coordinate. Okay, how do we find the y coordinates? When x is equal to 2, we are going to substitute this value inside the original functions to get the value of y. When x is equal to 2. Okay, so I'm going to bring this value, substitute this value into this function. Y is equal to 1 over 5, 2 minus 2, raised to the power of 3 plus 1. Okay, so 2 minus 2 you will get 0, 0 raised to the power of 3 is still 0, times 1 over 5 you will get 0, and here eventually you will get 1. Okay, now we know that the stationary point is 2, 1. Okay, so this is the coordinates of the stationary point. Second part, we need to determine the natures of each stationary point that we found. So we want to determine this stationary point is a maximum point, minimum point, or point of infraction. You can use first derivative test or second derivative test. Okay, here let me show you second derivative test. Dy by dx is equal to this, 3 over 5 x minus 2 squared. So we do again, differentiate this again, then we will get the second derivative, d2y by dx squared. Okay, so 2 you bring down here, times 3 over 5 you will get 6 over 5, and this is x minus 2, 2 minus 1 you will get 1, differentiate inside you will get 1, you don't have to write 1 actually. Okay, so d2y dx squared is equal to 6 over 5 times x minus 2. Okay, so I want to test this point, right? at point 2, 1. I will just need to substitute the x coordinates into the second derivative. So that d2y dx2 dx squared is equal to 6 over 5 times 2 minus 2. 2 minus 2. You will notice that you will get 0. When the second derivative you get 0, it is inconclusive. It means that we still cannot make a conclusion whether this stationary point is a point of infraction, maximum point or minimum point. So we need to go back to our first derivative test. Okay, before that, let me draw a table for you first. Okay, I have drawn the table, so now we can start to use the first derivative test to test whether this stationary point is a maximum point, minimum point, or point of infractions. To 1. Okay, so this is 2, right? We take the x coordinate to test, right? 2 here. And this number slightly smaller than this 2. How about we choose 1.9? And this number slightly larger than this 2. Okay, we take 2.1. So next, we want to find the value of dy by dx. So you can take out your calculator. And then, okay, hold on. You just need to key in the functions for the first derivative dy by dx. Okay, so this is a gradient functions dy by dx, right? So 3 over 5 parenthesis and x minus 2 x minus 2 raised to the power of 2. Okay, so we are going to ask the calculator to help us to get the value for dy dx. We press calculate, then key in the 1.9, the value of 1.9, the value of x, that we are going to find the value of dy dx. Press equal to times, you will get this 3 over 500. You can write fractions, or if you want to change to decimal, you can just change to decimal 0.003. 0.003, sorry, should be 0.006. 0.006. Okay, so now we can test by using the value of 2 here. Definitely we will get 0 because this is a stationary point, right? X stationary point, we know that the dy by dx must be equal to 0. If this is not 0, it means that we did it incorrectly. So press calculate, then key in 2, press equal, we get 0. Okay, how about 2.1? Press calculate again, 2.1 equal 2 times, you will get this 0.006. Oops, sorry, this one should be negative, right? Let me calculate again. Calculate 1. Okay, I think it's positive, correct? Should be positive. Let me check, double check again. Okay, correct, positive. Both are positive. So this is 0, this is 0.006. Okay, so this is positive, this is 0, this is positive. Now we want to sketch a tangent. So if the gradient dy dx is a gradient function, it tells us the gradients of the tangent. So positive, it means that the tangent go up this way, right? And 0, tangent will be like this. And then positive, the tangent go up this way again. So you will notice that these two same sign, right? So when if you want to add one more column sketch of the graph, it will be like this. So from here we know that this is not a maximum point, not a minimum point, but this is a point of infractions. 2, 1 is an infraction point. Okay, so if you want to see the graph is like this. So 2, 1 is over here, So this is a point of infractions. Okay, let's try the second part. We have another function here. This is a cubic function. Y is equal to 2x raised to the power of 3 minus 12x squared plus 18x plus 3. Okay, we want to find the stationary point. Always remember, when we are asked to find the stationary point, we find the dy by dx. Because we know that x stationary point, the value of dy by dx will be always equal to 0. Okay, just differentiate this function. I think it should be no problem, right? This one. 3 times 2, you will get 6x squared minus 2 times 12, 24x plus 18. If you differentiate a constant, you will get 0. Okay, x stationary point. We know that the dy by dx is equal to 0, right? This whole thing is equal to 0. 6x squared minus 24x minus 24x plus 18 is equal to 0. So if you want to make the number become smaller, you can divide this whole equation by 6. So you get x squared minus 4x plus 3. Okay, so correct. Then we do the factorization for this quadratic function. Okay, this quadratic equation. So you have 3 here, 1, negative, negative. Okay, correct. X minus 1 is equal to 0, or x minus 3 is equal to 0. So we know that x is equal to 1, or x is equal to 3. So we have two stationary points here. When x is equal to 1, we want to find the y coordinates. So I'm going to bring or substitute the value x equal to 1 into these original functions. Y is equal to 2, or how about I copy first? 2x cubed minus 12x squared plus 18x plus 3. Okay, so I'm going to substitute this value inside this function. All the x, I will change it become 1. 2 times 1 to the power of 3 minus 12 1 square plus. Okay, so this one you can just press your calculator. You should be able to get 11. So now we know one of the stationary point is 1, 11. How about when x is equal to 3? When x is equal to 3, y is equal to, now we are going to bring this value x equal to 3 into this original functions. 2 times 3 to the power of 3 . Okay, what I'm doing here is actually replace the x by 3. Okay, you can just use a calculator to help you to calculate it. Is equal to 3. We got another stationary point. 3, 3. Okay, and then now we need to test. We need to determine the natures of each stationary point. Which one is maximum or which one is minimum. So same thing, you can use the first derivative test or use the second derivative test. dy by dx is equal to 6x squared minus 24x plus 18. So here I'm going to show you second derivative test. I find the second derivative d2y dx squared. 2 times 6, 12x minus 24. Okay. at point this. Now I test this point first, then only I test this point at point 111. So what we need to do is just substitute the value of the x coordinates into the second derivative. 12 times 1 minus 24. Here you will get negative 12, right? Less than 0. Less than 0, it means that it's a maximum point. 111 is a maximum point. Okay, now how about this point? At point 3, 3. We do the same thing. We substitute the x coordinate. We only take the x coordinate. Okay, take the x coordinate, substitute into the second derivative. 12 times 3 minus 24. 36 minus 24. This is 12. Greater than 0. Greater than 0, it means that minimum point. I hope that you still remember this. 3 is a minimum point. Okay, so this is a way how we find the stationary point and to determine its nature. So if you want to see the graph will be like this. 111 maximum point, right? And to be more accurate, it should be called local maximum, but your textbook using maximum point, so it's okay. We can just call this maximum point, and this is local minimum or minimum point. Okay, this is 3, 3. Okay, so this is a way how we find the stationary point and determine its nature. Actually, here we have a point of infraction. I think it's somewhere around here. This is a point of infraction. But we don't have to find this point, because this point of infractions, the dy dx is not equal to 0. That means this point of infraction is not a stationary point. The question is asking about stationary point, so we don't have to find this point. We only need this point and this point. Okay, now let's try part C. Y is equal to x raised to the power of 4 minus 3. Okay, find the value of the gradient function first, dy dx. 4x cubed. Okay, so x stationary point. Dy by dx is equal to 0. Just do what we did just now. Almost the same. Okay, just the function is different, but the step is still the same. 4x cubed is equal to 0, so we know that x cubed is equal to 0, x is equal to 0. So next step, we find the y coordinate. When x is equal to 0, y is equal to 0 raised to the power of 4 minus 3. Okay, so the stationary point will be -0, -3. Okay, next we need to test or determine the natures. So you can use the first derivative test or you can use the second derivative test. But remember, when you use the second derivative test, if you get the value is equal to 0, then you have to go back again. You have to use the first derivative test again, because when d2y dx squared is equal to 0, it is inconclusive. We still cannot make a conclusion that that point is a maximum point, minimum point, or point of infraction. We have to use the first derivative test. So here, if you try to find or try to determine the natures of this stationary point by using the second derivative, you will get this. Okay, this is the dy by dx, right? So if you differentiate it again, you will get 3, 4, 12 x squared. When x is equal to 0, you plug in here, you get 0, right? At point 0, negative 3, d to y dx squared is equal to 12 times 0 squared. You get 0. It is inconclusive. We still cannot make a conclusion that this point is maximum point, minimum point, or point of infractions. So we need to use the first derivative test. Draw a table first, then just fill in the information, the value of x that we need. Okay, so the stationary point is 0, right? We put 0 here, and this number slightly smaller than 0, negative 0.1. Okay, this number slightly bigger than this number, then 0 will be 0.1. Okay, so dy dx should be no problem, right? You just key in your calculator this function 4x cubed, and then press calculate, and then key in this, and this. Then you will be able to get all the value of the dy dx. Okay, how about let me show you. So first, key in this function, gradient function 4x power 3. Okay, press calculate, and then key in the value that we need, negative 0.1, negative 0.1. Press equal to time, you will get this. If you want to change it to decimal, also can, negative 0.04. Then calculate again, key in 0, we should be able to get 0, this one. Okay, then press calculate again, key in 0.1. Okay, this is a positive value. So the most important thing in this part, when we determine the nature of a stationary point, is actually not the value of the dy by dx, but it's the sign, positive or negative. So this is negative 0.004. Oh, sorry, negative, yes, correct. This is 0, and this is 0.004. Negative, 0, positive. Negative, the gradient go down this way. 0, gradient go this way. Positive, gradient go this way. So if you want to add one more column, sketch of the graph or sketch of the curve, you will need to draw this one for that column. I mean, if you want, let's say if you want to add one more column, here you can write sketch of the curve. Okay, so this is a minimum point. This stationary point, 0, negative 3, is a minimum point. Okay, so if you want to see the graph, this will be the graph. 0, negative 3 here, minimum point. Okay. Okay, so this one you can test by yourself. You should be able to get one of them is a point of infraction. We have two stationary points over here. Here, one stationary point, this is point of infraction, and another point is over here. This is stationary point. These two are stationary point, but this is point of infraction, and this is local minimum or minimum point. Okay, this one you can try on your own. Now let me explain one more example. The diagram shows right angle triangle ABC. The vertices PQR of a rectangle BPQR lies on BC here, and then CA, and also AB. Okay, given BP is equal to X and PQ is equal to Y, we want to show that Y is equal to this. Okay, so here We want to express y in terms of x. Now you see a right angle triangle. When we see the right angle triangle, we always think about the trigonometry or the Pythagorean theorem, right? Okay, how about we find BC first? BC. BC is equal to 26 square minus 10 square root. Okay. 26 square minus 10 square root. Okay, you should be able to get 24 centimeter. So here is 24 centimeter. If this is 24 centimeter, the PC will be 24 minus x, right? P under C, 24 minus x centimeter. Okay, so now we actually have two similar triangles, right? This triangle, and another one is this triangle. These two triangles are actually similar triangle. So we can use the property of similar triangle to help us to form an equation. Y, the corresponding side of this will be AB, right? So y divided by 10, y divided by 10 is equal to PC divided by BC, because the corresponding side of PC is BC. This is smaller triangle and this is bigger triangle. 24 minus x divided by 24. Okay, we just bring the 10 over here, become multiply. So we simplify it, divided by 2, divided by 2. 5 times 24. Okay, how about I write this first? Okay, so y is equal to 5 times 24, you will get 120. 5 times x, 5x. 12. Okay, correct? Yes, correct. Shown. Okay, next part. We want to express the area of rectangle BPQR. This rectangle BPQR in terms of x. Area of rectangle BPQR is actually equal to x times y, right? And the question asks us to express the area in terms of x. It means that we have to represent or replace the y by x. Since we know that y is equal to this, so we are going to substitute this whole thing inside here. We don't want to write the y anymore, but we write this. 120 minus 5x over 12. Okay, so we just multiply the x inside here. You will get 120x minus 5x squared over 12. Okay, so this is the area of rectangle BPQR in terms of x. Last part, find the maximum area of the rectangle. When we look at the question, ask us to find the maximum or minimum, we always think about the dy dx, right? Because at turning point, maximum point or minimum point, the value of dy by dx will be equal to 0. Okay, so area, I just write A to represent the area of rectangle BPQR is equal to 120x minus 5x squared over 12. Okay, you can start to differentiate it. If you feel that complicated, ask to do the differentiation in this form. You can actually change it. They are sharing the same denominator, right? Okay, then we find dA dx. Okay, how about let me simplify it first. make the number become smaller, so easier for us to do the differentiation. Simplify it. 10x minus 5 over 12 x squared. Okay, now let's find the first derivative, dA dx. 10 minus 2 times 5 over 12, you will get 5 over 6. The power here, you have to minus 1, remember. So dA by dx is equal to 10 minus 5 over 6x. Okay, now we got the first derivative. We know that for maximum, the dA by dx will be equal to 0, right? At turning point, dy by dx is equal to 0. So it means that this whole thing is equal to 0. 10 minus 5 over 6x is equal to 0. Negative 5 over 6x is equal to negative 10. X is equal to negative 10 times negative 6 over 5. Okay, so x is equal to 12. It means that when x is equal to 12, the area of this rectangle is the largest one, maximum. So if you want to test, you can find the D2. Okay, let's say if I want to test is this maximum point. Since the question asks maximum, right? And we got only one value, so definitely this will be the value for the maximum area. So if you want to test, let's see how do we test. We find the D2A dx squared. Differentiate this one, you get 0. Differentiate this, you will get negative 5 over 6. We don't have to substitute any value of x inside the second derivative because after we differentiate it for the second time, we have no more x here. Negative, this is less than 0, right? So we know it's maximum point. Okay, so the question asks us to find the maximum area. We know that when x is equal to 12, the area of this rectangle will be maximum. So when x equal to 12, what is the area of this rectangle? Maximum area of rectangle BPQR will be equal to, okay, so this is the area for rectangle BPQR, right? So I'm going to bring the 12 inside here and here, and then press our calculator, then we will get the maximum area. Okay, so the answer is 60 square centimeter. Okay. (60 square centimeter). Okay, so this is the final answer for this questions. But okay, so for this video I stop here first. Thanks for watching and see you next time. Bye bye.